So we're going to see which side of our magnets are north and which side is south. And we've got a compass here to help us, and I'm going to lay it down and see which way is pointing north, and then I'm going to spin our magnets to see which way points north, to see which side of the magnet is north and which side is south. And we don't want to get too close to the compass because it does draw the arrow to the magnet, and so it may make it spin because, again, this has got magnetism, and if I put this really close to it, it will actually spin it, make it spin around because of that opposites attract thing. The south pole is pulling it, the north part of the magnet, toward itself, so it spins around. So you want to kind of keep it far enough away to where that's not happening. So I'm going to lay that one on the table just so I know where north is. And then I'm going to hopefully get this string back on. But because of these bar magnets, sometimes you can't hold them flat like this to do them. You sometimes need to hold them this way because they tend to attract more to the larger surface. So I'm going to hold mine this way. In the curriculum, it shows you a different way, so it depends on the magnet. So you can see that it's spinning. You may want to hold it a little closer. And according to the compass, north is pointing that direction. So this is the northern side of our magnet. We'll see if that's correct by seeing if this will attract or repel. So this has to be our south side. So we'll see if this is the north side of the magnet. So if this is correct, and I've actually going to mark on this one an N. You can use a marker just enough so you can see the N, so that I know that's the north side. So I'm going to check this other magnet, find its north side, and then if it attracts to the opposite side of the one I've marked, then I've got the correct side, and I've done the experiment correctly. So same thing with this one. We're going to hold it. And you have to be patient. And remember when you're dealing with magnets not to put these near your computers, your cell phones, your cameras, anything electronic pretty much, because they will wipe your data out. So please be careful when you're dealing with magnets to have no phones or cameras around or computers around. And don't be trying to be funny with them because that can do a lot of damage to your electronic devices. So I'm going to mark this one. Now I know which side is north on both of these, so I'm going to see if they attract or repel, and they're not attracting very well. So let's see if, oh actually that's the south side, so that was why I was pulling close. So I want to turn it to the north side that I've marked and see if they will go together, and guess what? They will not. So more than likely we have it correct. We have the north trying to hit the north, and we remember north will not go to north and south won't go to south. So let's turn them over and see if that happens. It does. So let's see if a south, which is not marked, and a north that is marked, attracts. So that's attract and repel. That's your lesson 10. Be careful again not to pinch your fingers in doing that. There's also information in this curriculum about closing the circuits, and to determine whether a magnetic strength of a magnet is the strongest. You can hold a bar magnet by one of its ends and bring the other end of the magnet close, and come in contact with a paper clip or another metallic object and see how far away from the paper clip you can get before it picks up. So there's other activities that you can do in this lesson, but this is the way you can tell your north side of your magnet and your south side of your magnet and use a compass to begin.